All right. Consumer surplus. What is it?
Supply in the marketplace.
Excess supply in the marketplace. No. But what does excess supply in the marketplace? What does that look like? So I just want to follow up with Mac's statement because it's good to bring up these topics here. So you guys should all have home base down packed here. That any market situation we talk about, in theory, is at some status quo, some starting place. If it's in equilibrium, it would look like this. If it's not in equilibrium, it would look like Max's situation. If there is a surplus, or what did you say, excess supply, which is fine too. So if the price in this market equilibrium is at $10, but for whatever reason current prices are at $12, then the quantity supplied is greater than the quantity being demanded, causing a surplus or excess supply. So that's what you just described. And if we were looking at this in a functional form, would the P or the Q be to the left side of the equal sign? If we were looking at this function, if we were to put that into an equation form, would the P or the Q be on the left side of the equal sign? Left side, good. So this is the vertical axis variable, the y-axis. I try to avoid using y and x-axis because we talked about usually anything but x's and y's in this class. So slope-intercept form is what will generally stick through for most of the course, not always when it comes to supply and demand, just for simplicity. And so the y-axis is the p-axis. And so is that the regular supply function or the inverse supply function? Regular. Agreed? So if we have something P is equal to some function of Q, that's a generic representation of the formula. Or we could say A plus B Q if we're using slope-intercept form. Some sort of intercept, some slope, the Q. Right? So that would be putting a little more meat on the bone, so to speak, giving a slope-intercept form for the function. Was that the supply function or the inverse supply function? Max says supply function. What is the story we tell for the supply curve in general? I mean, if you were to describe what's going on here at $12, how would you put that into words? Between prices, price goes up, quantity supplied goes up, true, okay? So at a price of $12, the quantity supplied is some amount, right? Whatever that amount is, 100 units. So if we were to tell that story in terms of an equation, how should we express that? Which one's the independent variable? Which one's the dependent variable? Independence price, good. So in a functional form then, where do independent and dependent variables belong? What goes on the left-hand side of the equal sign? What goes on the right? Dependent goes on the left. Good. So it's Q equals some function of price, right? So the quantity supplied is a function of prices. There's other things that are in there too that end up shifting the curves, right? Other important variables like the cost, the price of resources, the price of substitute outputs, related outputs, expectations, technology, the number of suppliers, all of those things could ultimately affect the quantity supplied by a particular firm. Okay? So we're just focusing in on price to keep things simple for now. And so the quantity supplied is a function of price. Regular supply function or inverse supply function? Regular. So this is the real story going on. So this is the regular. So try to think of this as, if I was going to tell the story of a business, the quantity that they supply is dependent upon the market price. And so that's kind of the regular story. That regular story doesn't fit this graph though. So the inverse supply function is this one. So if the P is on the left-hand side, it's the inverse supply or the inverse demand. If the quantity is over here, it's the regular demand function or the regular supply function. Okay, as long as you brought up surplus, Max, if prices are too low, what do we have? Shortage. So if prices are down here at $8 for whatever reason, mathematically, we'd substitute an 8 into this equation, whatever it looks like. We'd substitute an 8 into this equation, and we'd get an answer. And that answer would be the quantity demanded, not this equation, sorry. It would be a demand equation that I'm not showing. We'd substitute an 8 into the regular demand function, which is also a function of price. We'd substitute it in there, we'd get an answer of some number. Then we'd take the 8 and we'd plug it into the supply function and we'd get some number down here. And since the quantity that people want to buy is greater than what is actually being produced, we have a shortage, or an excess demand is another term we can use for that. Okay. Questions there? So if I'm going to kind of summarize what we just said, which is a bit of a flyby here, price is the independent variable. So for any given price, you can calculate the quantity demanded or quantity supplied by subbing that price into the demand or supply equation. All right, so let's see if we can get back to the original question I asked, which was consumer surplus. What is consumer surplus? Too many people consuming the product? No. So if there's, I guess the closest thing to that would be this shortage maybe, that there's too many people wanting to consume the product compared to what's there. So consumer surplus really shifted gears on us back to how we think about the valuation people place and somewhat the benefit that they get from the market transaction. Because there's some people that are willing to pay more for the good than what they actually pay. Right? So that was the thing with consumer surplus. The demand curve implicitly stacks the people who place the highest value of the good as being the first purchasers. So you can kind of imagine, like, if we started the good up at this price here, just to kind of work with this example, let's just say this is $15. Nobody would buy this product at $15. It's just too high of a price. So this is called the choke price. The choke price. It chokes off all consumers if it gets to that high. 0 consumers want to buy it. Mathematically, what does it represent for the demand equation? The y-intercept, yep, the vertical intercept. So that's the choke price. So then, as we tell the story of, well, suppose we cut the price to $14.75. All of a sudden, somebody jumps into the market. Who jumps in? The person who's willing to pay $14.75, right? So somebody has a value of at least $14.75, but nobody else will come in. As we cut the price to 14, more people start jumping into the market, right? That's the law of demand. As the price falls, the quantity demanded rises. All right, so this then starts to bring us to the concept of consumer surplus. Once we have determined the equilibrium price and quantity of $10, these people didn't go away, right? Somebody out there valued the good at $14.75, but they're getting it for $10. And so for that second unit, or whatever number that was, this person garnered $4.75 worth of value. They got a deal. They paid less than what they were willing to pay. And that happens all the time in the market system. So we capture that value to consumers by adding up those values over all units that ultimately get consumed, tell that same story, and that ends up being consumer surplus. So, consumer surplus is the difference between what a consumer is willing to pay, which is the height of the demand curve, and what he or she actually pays, which is the market price, or the sale price, whatever it is, and what he or she actually pays for each unit consumed. Your textbook definition is close to the same, but I think I liked mine better if I remember right. But they do tell the same thing. Let's see, where is it? So the consumer surplus, as the textbook has it here, the difference between the amount consumers would be willing to pay for a good or service and the amount they actually have to pay. So that's basically saying the same thing. The difference that I'm highlighting for you, because I've seen students have this pitfall over and over, is adding this for each unit consumed. The text said that, but it didn't emphasize it. And so in this case, if there's if the price in the market's $12, there's a quantity of 100, but that's not how many the consumers are actually consuming, right? They're only buying this amount. And so you got to be careful on making sure you've got the right number of units being the actual ones that are consumed.
Because all the individual units that are being consumed make up the entire triangle of consumer surplus.
Yes.
That-
Yeah. Yeah, at the aggregate level, that is consumer surplus. Now, for some problems then, you're going to have to calculate that area or that amount. And so sometimes it's a triangle. A lot of times, especially in the beginning stuff, it's a triangle, but it doesn't have to be. So if it's this triangle, how do we calculate it? 1/2 base times height. Good. So the good old 1/2 of base times height. We've got a height of 5, right? $5. We've got a base of whatever the equilibrium price is, calculate it out, and that gives us consumer surplus. And another highlight, or maybe a thing to note here, is that it's a dollar value measure of welfare. It's a dollar value measure of welfare. Because when you calculate that area, it's price times quantity, or it's dollars times quantity. So it actually gives you a dollar value measure, not utility in contrast, or benefits or something. Okay. On the producer side, we have a similar thing going on. The minimum amount that a producer needed to get to bring this unit to market, let's say this is the second unit, the minimum amount that they needed to get to bring it to market was this amount. We'll learn later and emphasize again, but from principles class, the supply curve is the marginal cost curve in a competitive market. And so this really reflects the marginal cost, which would reflect the minimum amount needed to bring that second unit to market, right? And so in reality, they end up having this many units at the market, selling for $10, and so the marginal profit, if you will, on this particular unit is that vertical distance. And then we do the same thing for all of the units, and this ends up being the producer surplus. So producer surplus is the difference between the price the producer actually gets, which is again the market price in this case, and the minimum amount needed, which is the height of supply curve. And I'll put / marginal cost curve. For this one, I might add the note that this is similar to profit, but not exactly, because it doesn't look at fixed cost. So similar to profit, but excludes fixed cost. We'll come back to that topic later, but it's kind of helpful to think, oh, okay, so if I do 1/2 of base times height for this little triangle, I get a dollar value measure. That dollar value measure is kind of like a profit, but it's not exactly what we'll get into later with the total profits for the firm.
This is the marginal cost curve.
Yeah, yep. And so we kind of usually truncate it like that. Yep. Okay. So that was maybe more background than I was even planning to get in. Pull out your sheets. And let's look at the first one that I think has the C3, yeah. So you've got a demand and supply curve for newspapers in a Midwestern city are given by those two functions, where Q is measured in thousands of newspapers per day, and P is the dollars per newspaper. Find the equilibrium price and quantity. Calculate the consumer and producer surplus at the equilibrium price. What's your first step? What are you doing? What's going through your brain? What's that? Set them equal. Okay. As soon as you get an answer, let me know what you got. Price is 75 cents. My marker's getting low already. 137. Anybody get anything different than that? Did you guys get that? Good? Okay. Keep plugging along then. That sounds good.
Do you want us to draw the graph of the price on the vertical axis?
If you want to do a graph's not required, but yes. That would be the appropriate way to do the graph, yes. And it might be helpful. What are you doing next? Okay, good. So trying to rearrange formulas to get the P's over there. As soon as you get some choke prices, let me know what you got. Compare notes. Get something, Taylor? Oh. Stuck, Colby? so with that picture, we need to find these choke prices. So you want to solve for that, which is the vertical and horizontal, or the vertical intercept for each function. In order to do that, like Blake said, start to solve the function for P.
Okay.
All right, so which you're solving for the inverse supply and the inverse demand curve.
Okay.
So if you solve that equation for P, then you can determine the intercept, and solve this one for P, you'll solve for the intercept. So you need to get that choke price.
Oh, so those are the.
152. You're on the right track, but not quite there. So if you do 152, the quantity demanded is 152 minus 20p. That's our demand function, but that's not the functional form here. So the choke price is from the inverse demand curve. So that's where you need to solve for P. Blake, did you come up with something yet?
7.6.
What's that?
7.6.
7.6, that's right. So this would be 20p equals 152 minus QD. P equals, and then 152 minus, or 152 divided by that gives us the 7.6 here, right? And 0.02, yeah, 2 cents is for the supply. Yep. Now, another way you can do this, well, there's a couple different ways. You could set Q equal to 0. Check this out, you guys, because this would be maybe an easier way. Take this form, set Q equal to 0, and solve for P, right? So you can transform the whole equation, which is fine. Then you'll get your 7.6 minus the 1/20th QD. There's your intercept, 7.6, or just set Q equal to 0. So you're going to find with a lot of these problems, there's a couple different ways to maybe get the solution. One might be easier than the other. So yes, I heard somebody say 0.02 is our choke price for supply. 7.6 is our demand choke price. And that should give you everything you need to calculate consumer surplus and producer surplus. So as soon as you get an answer, anybody get consumer surplus? 469, 2.225. Okay. Anybody get producer surplus yet? $50.005. Now, a couple things here. Is this a number? Is this a percentage? Is this what is this? It's a dollar value. So in both cases, it's a dollar value. Now it turns out both those answers are wrong. They're real close, but I want you to go back up to the beginning of the problem and read it again. So the demand and supply curves for newspapers in a Midwestern city are given by these equations, where Q is in so watch your units. So this is not 469.22, it's 225. So the dollar value of welfare is $469,225 because we're measuring this in thousands. And this one's 50,000. So those are the correct answers, but be careful with your units. Remember the last problem we went through had the price measured in pennies. Remember it was 108 cents, which is also $1.08. So depending on how the question's worded, be careful with that. Okay, any questions here? Anybody not seeing the math? All right. So, what's the next problem? Flip it over. Unless do you guys have any follow-up questions? Everybody, you got to be crystal clear on this, honestly. So maybe I'm rushing too fast. Is there any little tiny thing you do not get about this? Be honest. It's okay. This is the time we got to flush this stuff out. I left some things blank. I didn't do it intentionally. I'll be happy to fill them in.
I'd like to fill in.
Okay. So on the, oh, you didn't have your calculator. Yeah, start bringing your calculator because we'll be doing quite a bit of that. So 1/2 of the base times the height. So the base is 137, but as we learned, it was 137,000. And the height for consumer surplus was the 7.6 minus the 75 cents. Okay, so $7.60 minus the 75 cents gives you the height. Multiply that out, you should get that. Producer surplus, same base, different height. We got 75 cents minus 0.02, giving us 73 cents. Okay?
So when we figure out the inverse functions of the supply and demand curve, that gives us the actual supply curve that we're looking at, correct?
Yes. So always, you got to memorize that right now as soon as you can. Our picture that we've been comfortable with in principles class is the inverse demand curve and the inverse supply curve. It's always the one with the P on the left-hand side of the equal sign. But as you calculate out problems, you may need to use this functional form, or you may, and we're going to see that in the next, I think the next problem we do. You might need to use the regular demand or supply function or the inverse demand
So
function.
when the quantity's on top and the price is on the bottom, we haven't figured out the inverse function. What is that? That's just
When the elasticity, or what?
the inverse function allows us to derive the actual supply curve that we're looking
Oh,
at. What is it? What does it mean the other way?
so with the other way, you're determining the quantity. So the problem that we did last time when we shifted, oh, you weren't here last time. We shifted the, what was it, you guys, the supply curve by 400 units. So the problem, I gave you that sheet though, I think, didn't I? Okay. No, oh yeah, was that Wednesday? Yeah, okay, so remember when we decreased the supply by 400 units?
Yeah.
So then we had to use the quantity. So the way the question was worded, we were subtracting 400 units from the quantity. And so then you'd want to use this to tell the math of that. We subtracted 400 units. So that's one example where you might use one or the other.
Wasn't there a way that we could do it when the Q was in the front, but just go from the x-axis? Or I don't mean to say x-axis, but just go from the quantity.
Yes, there would be a way to calculate it that way, but it's probably more confusing than it's worth. But yes, in theory, I think you could do it, but there'd be enough mental gymnastics that I'm not sure it's worth doing.
So in micro, when we were looking at the graph as the Q is on the y-axis and the P is on the x-axis, what is that?
Over where Q is on the what?
The y-axis. Because you were just saying that now we were looking at, we have to figure out the inverse function.
So if you were to graph, the regular function would look like this, but that doesn't marry up with the traditional supply and demand framework. Okay, is that it? Now, pretty shortly we're going to get into Q-tips and pretzels. And they're going to be measuring quantities on both axes, and there's going to be some mathematical equation that describes the relationship between pretzels and Q-tips and your consumption behaviors as a person, as a human being, and making your happiness. So we'll get there in a second. So right now, I think the important takeaway is always remembering the vertical axis variable, if we fall back to a slope-intercept form, means that it's over here. And this is the demand equation. The inverse demand equation has the P on the other side. And that's why we call it the inverse demand. We've inverted it, right? We've kind of flipped it around and inverted it. Okay, anything else on this? Any last morsel? Blake, we got your question? You had your hand up, yeah? Okay. Ooh, okay, maybe we will save that one for Monday, or Wednesday. Okay, yeah, it's a little too late to jump into that one right now. So this kicks off chapter 3. So if you want to, especially since we're don't have class on Monday, if you want to read ahead, you could get at least somewhere chipping away into chapter 3, but certainly through chapter 2, and you have the learning curve for chapter 2 due.
On Monday?
I'm okay since I said Monday before because I forgot it, the Labor Day break. So let's just make it Tuesday by midnight is fine. So, okay? All right.